The question was, given a mold for a sailplane fuselage, how to limit the toolpath just to the area that needs to be cut. And the answer is boundaries. Gonna incorporate some of the things in recent videos by Apollo and Burman, who respectively talked about selection masks and the use of layers. So I've got a mold, I've got it set up, I've got my stock set up. That much is done, so now I need to generate the boundaries around the actual cavity that I want to cut. The way I do that is to make a new layer, going to name it boundaries, and we'll go into it where it's active. Now I want to extract some edges. Extract edges from the mold, that is. I will take that one, that one, that one, and that one. Hit OK. Now I'm going to turn off the layer where the mold is, so now you can see that I have some wireframe. Go to a top view. Going to select everything except the geometry running down the sides of my cavity. And I'm going to delete everything. Then I'm going to use line join. To just make a rectangle. Okay. So what the boundary is basically a fence, and it tells the system to keep the toolpath within the fence. If you tell it to cut inside there, you can also put some geometry in there and it will not cut into that geometry. So if I put, you know, a rectangle in there, it would leave a rectangle sitting there all the way up. To make this easier to get a hold of, I'm going to raise it up a couple of inches in the Z-axis. Just select everything, positive Z. Boom. Alright, now I'm going to turn back on my solid. I've got both layers showing now, so I have my boundary and I've also got the mold itself of the cavity and all. Now tool pathing is something that you really are not going to get a whole lot of on this particular one. I'm going to do a quick roughing tool pass, I'm going to do a quick finishing tool pass. They are very much dependent on what you want out of the part. Different tool paths give different finishes, different amounts of sanding, different kinds of sanding. There's way too much to go in here. So I'm going to go to mill 3 axis. I'm going to go to Z level rough. This is going to be my roughing tool pass. I just want to blow a lot of stock out of the way. I'm going to select everything. Going to deselect my boundary. Hit OK. Now I'm going to select boundary. And I'm only going to select my boundary. Hit OK. So now I have geometry selected and a boundary selected. Go to next, rapid plane, 1/10 of an inch above the part, top of part 0, that's top of stock, that's good. Arc fit is not an issue in this tool pass. I'm going to just use a straight end mill, 1/4 inch straight end mill. And my machine, 120 inches a minute. Give it 40 inches in Z. We'll say pocket in, climb mill, pocket in, pocket out are both different options in Z level rough, or Z level finish for that matter. Depth of cut 1/10 of an inch, step over 1/10 of an inch, those are both also okay. I'm going to leave in 300. So I'm going to come back in with a 1/4 inch ball nose end mill for the finishing pass. There are no holes to ignore, I'm not going to worry about that. Top of job is at 0. Plunge entry is fine with me. Because I have boundaries, I don't have to worry about some of the advanced features like innermost or outermost. I can just tell it to cut everything. There's only one area in this part, so I'm just going to leave it by area instead of by level. And we'll finish. Now go back, reselect geometry, looks good, so I hit OK. Reselect my boundary, boundary selected, that's good, OK. Compute toolpath. Now I'm going to go ahead and do my finishing toolpath really quickly, and we'll simulate them both at once. The finishing toolpath, I'm going to use a slice planer. Probably, I don't see any real reason not to just run lengthwise down the part, so we'll go with a 0 lace angle on that. Okay, slice planer, select geometry. Just going to select everything again, and then deselect my boundaries. Okay, select boundary, I can shift click for the rectangle, and that's okay. Next, my rapid plane, top of part are both fine. In this case, once again, arc fit is not an issue. I'm not going to be doing arcs with a lengthwise cut. If I were going crosswise across it, constantly doing a U shape, then arc fit would really be your friend. But in this case, I'm going to be just basically running straight lines, so no problem there. Next, I'm going to pick a 1/4 inch ball nose end mill. Speeds and feeds on my machine, I can probably get by with 48 inches a minute, and just keep a nice quick plunge. That's just a time saver because you're doing a lot of passes. Alright, gonna do zigzag, so it'll be a mixture of climb and conventional. Lace angle of 0. While I'm doing that, I can't do this. This is oriented lengthwise in the x-axis, and x positive is out here. In everything that I know of with BobCAD, when it refers to angles, 0 and 360 are in the positive x-axis normally. So you'd have 0, 90, 180, 270, 360. So 0 is going to be lengthwise, long ways on the part. We'll go with climb mill, but it is zigzag, so every other pass will be conventional cut. Step over. You don't want to spend too much time sanding it, so you've got to go very fine here. That's why finished passes eat up time. We'll go 3/1000 with the 1/4 inch ball mill. That won't be very much in the way of lines. Because it's lengthwise and this is a sailplane fuselage, you're going to get a very, very minuscule extra amount of drag out of it if you don't bother to sand it at all. It's going to be a matter of the surface area, so really no biggie there. Allowance, in this case it's a finished pass, we'll say 0. Once again, there are no holes to worry about. Top of part is at 0. We're cutting to part depth. Plunge entry is fine. Vertical lead in, lead out, yes. Going to extents and not part bottom. We're really just cutting the trough there. Tool tip and not tool center. Follow instead of horizontal and vertical. That finishes that up. Again, I'm going through the tool pathing pretty quickly here because there's a lot to cover there. That's a matter for another time. Okay, reselecting my geometry, mold, that looks good. Reselect boundary, yes, my rectangle is still selected, that's good. Both okay. Compute toolpath. This is very fast because it's a pretty small number of lines. If the lace angle had been 90, that would probably take 2 minutes to calculate on my machine. Alright, this is V24, so I have pretty limited, well, it's not really all that bad, it's just a little bit clunky on some of the more complex simulations. Get this thing oriented the way I want it. Okay. Everything is posting, so everything will simulate. Run this up pretty fast. And get her started. Okay, so this is a straight in mill. You see it's just blasting out very fast, knocking out as much as possible. Now we switched over to the ball end mill. And there you go. That's how you limit your operations to a given area using boundaries.